Please welcome Mr. Ahmad Dhiya Irsyad.
So hello and good evening everyone. My name is Ahmad Irsyad and you guys can call me Dhiya as I've introduced previously. So for this technical presentation, I have prepared an interesting topic entitled Hydrogen as the Next Fuel, and I'll also be sharing some of the opportunities and challenges for Malaysia's energy transition. So before starting the presentation, I'll be briefly explaining some of the extensive overview on what I'll be presenting throughout this session. So first of all, I'll be explaining on why hydrogen is best suited as the next alternative fuel. I'll be explaining on how hydrogen suitability is based on its distinct key features and some of the hydrogen types and its method of production. Next, I'll also be explaining some of the opportunities that Malaysia can grab in harnessing the alternative fuel for its own benefit, and also addressing some of the key challenges during this energy transition. And in addition to that, I'll also be sharing some of the PETRONAS pursuit and effort in order to tackle the key challenges mentioned, and also some of the current developing project that they have done. I'll also disclose some of the strategy of implementation that they have put in action towards achieving sustainability. And lastly, I'll also share some of the UTP's collaboration in terms of being a foundation for research and also providing training and workforce. And I'll also mention briefly about some of UTP's contribution and collaboration with other third-party companies. So next. So let's dive right into it. So why does hydrogen is suitable to be used as an alternative fuel? So when we think about alternative fuel, we think about something that is going to be used in any combustion-related industry, or something that can be used to generate any power for any mechanism or any vehicle. So that is what hydrogen is being proposed. Hydrogen is going to be proposed as an alternative fuel for any feedstock or burning fuel in any combustion-related industry, and it can also serve as an energy vector or energy medium in any company or industry that is in demand of energy. So hydrogen is very versatile. It can be produced from many different resources such as fossil fuel, natural gas, or even renewable resources. And hydrogen can also be used in many applications. So hydrogen can be applied in most of the industry depending on its demand and needs. Hydrogen also has a very huge export potential in which it has a high energy density per unit, meaning that per unit mass, meaning that per mass kilogram that is being transported, hydrogen have roughly about triple the amount of energy density in comparison to your usual gasoline. So this will allow it for long distance trading and also storage purposes to be feasible. And lastly, hydrogen also helps in reducing carbon dioxide emission. As mentioned previously, hydrogen can substitute burning fuel in most combustion-related industry. So this helps in decarbonizing sectors that are difficult to decarbonize, mainly the waste sectors, which are sectors that have difficulty in reducing its carbon dioxide emission due to the nature of their own industry itself. So now that we have familiarized ourselves with why hydrogen is being best suited as an alternative fuel, I'll be explaining some of the different types of hydrogen and its method of production. So for production method, as mentioned previously, hydrogen can be produced from a few different resources, and the mainly used ones right now are hydrogen that is being produced from fossil fuels. So the way that we classify this is that we have to look in the method of production and also the feedstock or the material that is being used to produce the hydrogen. So for example, grey hydrogen is being produced from fossil fuels through the process of combustion, whereas green hydrogen is being produced in the process of electrolysis from any renewable resources such as solar power or wind power or even hydropower. And the last two, which is brown hydrogen and also black hydrogen, is being produced from combustion using coals. So a few different types of hydrogen that is being highlighted here is that grey hydrogen, which is produced using methane, blue hydrogen using natural gases, green hydrogen using water and renewable go. So how can Malaysia grab this opportunity in order to benefit, in order to step a foot towards sustainability? So Malaysia is, according to the geological location of Malaysia, it is abundant of renewable resources. So if we can able to harness the renewable resources that is located in Malaysia, we can slowly approach sustainability and also approach the transition from grey hydrogen into green hydrogen, which comes into my second point, which is industrial growth. So by decreasing the carbon dioxide emission, by switching from grey hydrogen to green hydrogen, this allows us to approach a new industry or a new sector in which it is green technologies, in which it studies about technologies that are a lot more sustainable towards the environment. So this will also help us take a step closer into the national goals that have been set by the National Energy Transition Roadmap that aims to have a net zero carbon emission by 2050. So in hindsight, hydrogen supports in providing a renewable energy storage, a cleaner fuel for the industry, and also opens up an extra job opportunities in green technologies. So now that we know on what opportunities that Malaysia has, some of the key challenges that they are currently facing right now is, first of all, in terms of cost. So to produce green hydrogen using electrolysis, the cost is very high due to the material that is being used to produce the equipment, which is the electrolyzers, using very rare and costly material, which is, for example, platinum and uranium. So in terms of infrastructure, hydrogen also has a unique property in which it has a low energy density per volume. This caused it to have difficulty in storage and exports due to its not being feasible in terms of cost, because it has a low energy density per volume in comparison with gasoline. So the way that we do this, or the way that we counter this, is that we need to either compress the hydrogen into a compressed form, or we need to transform it into a liquefied form for it to have the same energy density as your usual gasoline. So lastly is the water and siting. So to approach green hydrogen, it depends heavily on water availability for any electrolysis process and a suitable site for it. So roughly, it consumes about 9 liters of purified water in order to generate at least 1 kilogram of hydrogen. So this site also needs to be near or in close proximity with any renewable energy resources to meet the demand of electrical supply for any electrolysis process. So some of the PETRONAS pursuit or efforts that they have that PETRONAS has done is that it has been actively developing hydrogen projects and also partnerships around the globe. For example, PETRONAS has done a green hydrogen hub where the electrolysis takes place, and in close proximity with a hybrid hydro-floating solar at Terengganu, which harnesses the energy of hydropower and also solar panels to generate electricity. And this has been a continuous collaboration with DNB and also Terengganu Incorporated. Other than that, PETRONAS has also developed a new project, which is Sarawak H2 Hub at Bintulu, Sarawak. And this has also been a collaboration with Gentari and SDDC Energies in the Berhad. And some of its strategy of implementation to tackle the key challenges that have been mentioned previously is that PETRONAS has a dedicated hydrogen business branch in order to handle any hydrogen or low carbon energy opportunities, which the business branch is called PETRONAS Hydrogen in Berhad. PETRONAS has also done a few collaborations with domestic and international partnerships in order to study better conversion methods of hydrogen and also better transport forms. And lastly, PETRONAS has also done technology research and development in order to develop any electrolyzers that are most feasible in terms of cost and a lot more efficient in terms of hydrogen production. And so, in addition to that, PETRONAS has also set up an aspiration towards UTP, in which UTP is aiming towards net zero carbon campus by 2050. So, an initiative that PETRONAS has done is PETRONAS has installed solar panel roofs in the main attraction or main facilities at UTP, which is called the Chancellor Hall, which combines a huge auditorium where most of the major events take place and also a grand library. So by installing the solar panels, it has, based on the statistic of 2023, the solar panels have generated up to more than 8 million kilowatt hour per year, and also have saved more than 5,000 tons of carbon dioxide emission, which is taking a step closer towards sustainability. So some of the UTP role and collaboration in helping PETRONAS achieving this objective is that UTP has a role in research, in which UTP helps in researching ways or method in hydrogen production. For example, UTP has signed a Memorandum of Unity with China National Nuclear Corporation Overseas, or in short CNOS, to advance a lot more in nuclear research, as well as finding suitable sustainable energy. And UTP is also responsible in providing training and workforce in order to aid for the objective as well. So in hindsight, UTP serves as a training ground for future engineers to develop themselves. And some of the contribution worth mentioning UTP has done is mostly revolves around the center and curriculum. UTP runs courses about the fundamentals of engineering, as well as expose students to the current demand and needs of the industry at real time in the shapes of projects and assignments, so that they are well more aware of what they have to face when they have decided their career pathways. So UTP also have done some industrial collaboration. For example, UTP has partners with Total Energies Malaysia in subsurface fluids monitoring that help them to monitor fluids that is being stored on the ground. So as of now, this helps in managing carbon storage and possibly in the future, which is also hydrogen storage. So in conclusion, every small steps is very memorable and very meaningful, and it can contribute to a huge success in the future. As a famous proverb of Malaysia once said, sedikit-sedikit lama-lama menjadi bukit, which indicates that every small step counts. So that is it from me. I'll open the floor to any question.
Question and answer hopefully from our counterpart from NUS today.
I think that was a very nice presentation. I just have a few questions. I mean, maybe just a couple of questions. But,
Maybe 5%, 5.
just one or two. Other than hydrogen, are you guys looking at other form of alternative energy? Because besides hydrogen, there's also other forms of energy, such as using methanol, or even ammonia, or even even nuclear. Like recently, there's this small modular reactors that's there's also trending nowadays when it comes to alternative energy. And you mentioned that hydrogen has one of the highest energy density by parametric basis of comparison, meaning per kg is one of the most energy dense. But it also means that because hydrogen is very, it's not dense. Like you need to compress it a lot, and it needs to be stored at a very low temperature. Can I just ask what differentiated hydrogen from other forms of alternative fuel when deciding on which alternative fuel to go for?
Okay, so I understand roughly on the first question. So I'll explain the first question first, and then I'll ask for an explanation on the second question, I guess. Okay, so for the first question, I think you were asking about why. Sorry.
Okay. I think the big question is why hydrogen compared to other forms of
So right now, what PETRONAS has said, or what Malaysia has said, is to have a net zero carbon emission by 2050. And one of the pursuits that PETRONAS has set in order to achieve so is by prioritizing using hydrogen instead of other fuels that have a very high carbon dioxide emission. So right now, PETRONAS is considering hydrogen as an alternative fuel, but in future, if it happens to be that other alternative fuel, which you mentioned previously, has been proven to be a lot more suitable, I guess, to be proven a lot more suitable than hydrogen, then we will also consider that. Alright. So does that answer your question?
Yeah, but there's also some safety consideration, like with respect to hydrogen. Like for one, yes, it's very flammable, and it is very flammable. Yes, a wide flammability range, and also the fact that yes, it's very high in energy density, but that also means that the storage condition needs to be cryogenic and it needs to be kept at very high pressure. When you guys are moving towards alternative energy, you guys also need the infrastructure required to like support that. So besides that, is there any like plans to move towards in that direction in terms of having the infrastructure and the capabilities required to support it?
Okay, alright, thank you for the question. So, as of right now, hydrogen is still in its initial stages. So right now we are considering on ways on what best way to produce it first. Right now, Malaysia have not currently developing any methods or any ways in order to best transport it. But PETRONAS has done a few collaborations with other partnerships in order to study about that. So for now, what their main concern is on how the best way to produce it, and later on, maybe in the future, we will consider on how the best method in order to transport it, and also the storage facilities with its necessary specifications.
Wait, sorry, when you say how best to produce it, you mean the production method?
Yeah, the production method, yeah.
So that's by electrolysis also lah.
Yeah. Alright, so thank you very much. And I'll the floor to my colleague.
Thank you to Mr. Ahmad, Dhiya, Irsyad for that presentation. So next we'll be hearing another presentation from our friend from UT. This time the topic is mobility and sustainable campus transport, UTP's journey towards carbon neutrality. This presentation will explore UTP's ongoing efforts in promoting eco-friendly mobility solutions and its commitment to achieving a carbon-neutral campus through engineering, innovation, and sustainable practices. Please welcome our presenter, Ms. Harissa Sufeena.
Hello everyone. I'm Harissa, but for short called UTP. So my topic today will be mobility and sustainable campus transport, which is UTP's journey towards carbon neutrality. Next. Okay, so first of all, why mobility? Mobility is one of the key contributors on the carbon emission because in UTP, many students rely on personal vehicle just to go to their classes due to limited public connectivity and also time consumption. So this also leads to congestion, higher carbon footprint, and also not practical practice for our environment. This also leads to more global carbon dioxide emissions. Thus, UTP has taken initiative to make it lower in the carbon footprint. Next, so based on Dhiya's presentation, UTP has one of the aspirations which is NZCC. By 2050, we are aimed to use the solar power as one of our main resource for electricity. On top of our rooftop, there will more than 38,000 area meter per square that covered around UTP campus. Also, this is the academic building and the main chancellor complex. This is expected to cover 26% of our electricity throughout the campus. So in this NZCC, we got 5 main pillars that we want to utilize fully on the solar power. First is energy, water, waste, mobility, and also greenery. So my focus today will be mobility because it lies closer with us students and also the staff. Next. So before we go into the solution, let's face the reality on why this is matter for us. First is the high car usage. I can say that our parking slots are mostly full, especially during the peak hours. And this proves that students use their personal vehicle just to go to class, even though it's just like 15-minute walks. So there's also like limited cycling paths because the paths that we use to go to classes are connected with the parking slot also. So this have made the other using micromobility difficulty to actually go to the classes. And also Malaysia is very hot and it's also it's discouraging people to walk since they have limited cover pathway. So UTP has taken initiative to make it greener sustainability. Next. So this is one of the initiatives that we have to. First is the expansion of the penetration path and cover walkway around the campus. So by early 2024, UTP already established 1.7 kilometer of cover pathway around the campus from the academic buildings also to the hostel. It's also connected to our recreational areas where students can also go do their physical activities and have a rest at their hostels. Next is our EV chargers. EV chargers are located in one of our main buildings, which our chancellor complex, just to make it more accessible for the visitors or the visitors or the staff to charge their vehicles. So by the end of November 2024, more than 1,000 kilometers have been charged using these EV chargers on UTP. And also we got the designation of micromobility lanes. In our campus, there are separate paths which indicate that micromobility can be used and also the normal path for the student to walk safely. So micromobility is defined as a vehicle that can drive under 25 km per hour, such as scooters or bicycles. Next. This is our newest sustainable solution, which is EV bus. EV bus will be launching this November that have 74 capacity for the student throughout the campus, and it will happen to be every hours for students just to go to class from their hostels. And also the EV charge will be fully charged based on our solar power that have charged in our rooftop, from our rooftop. Next, based on this engineering and operational aspect, but for the EV bus, it's also like one of the lab practical for the students, because students can also go there and search and learn how the EV bus are operated. So they can learn how the battery management and also how the energy conversion between the solar and also to the electricity. So this initiative have been integrated from engineering aspect. First is the charging system. The student or the researcher need to know how to handle the peak loads, ensuring the stability, and also to integrate the renewable energies such as from the solar or the wind power. And also the road design. The road design must be designed carefully just to make the shuttle system to determine the optimal routes, the time, also frequency to maximize the usage, especially for students to go to classes. And also the vehicle capacity. Each person carries different loads, so we need to ensure that each of the students can go into the buses without going overboard. Okay, next. Okay, so this is the outcome for our initiative. First is the environmental or student impact. This is the UTP campus overview. So we want to reduce the emissions. By November 2024 or so, we already saved 70,000 tons of carbon dioxide emission, which is aligned with our NZCC. So I can confidently say that by 2050, UTP can achieve the net zero carbon campus. Next is the better accessibility. Due to the increase of micromobility usage in our campus, we already offered the parking, especially at the academic buildings, just to make sure that the student can feel confident leaving their belongings there with no case of stealing. and also the environment will be more safer because you can see the differentiate path between the micromobility and also the vehicle usage. So it will make the students feel more confident to drive in the road without actually going to the pedestrian path. So this is like the micromobility, the normal vehicle, and also we got like pedestrian path just to go to classes. So they got very many options just for them to go to class without having to use motor powered vehicles. Next, so the challenges and future improvement. So to be honest, the biggest challenges will be the behavioral change because how we want to educate them to use less vehicles and actually go walks. So I can find that doing awareness campaign is the main ultimate things that we can do just to make them more realize that higher carbon footprint will lead to more bad environment in the future. And also the technical readiness because since right now we only have 2 EV buses, so you cannot tampon all the students. But in the same time, I could say that there's like they cannot like accommodate all students to go to class on time. But with proper planning, they can use the bus or the micromobility to go to class on time. And also for the improvement, right now they are integrating the smart mobility apps for them to trace either the EV bus, what time they will move, from where to where. But it's still ongoing. But I could say that our Egypt team has done 70% of them. And lastly is the students' innovation. This is to promote how they want to make the schedule better to go to classes. So the conclusion is sustainability is a destination, is a daily practices because it's a cumulative strategy just to make our environment more greener. Question.
Okay, so my question is like, so this EV bus, shuttle bus, right, I feel like it's more targeted towards the students that stay in the hostel, is that right?
Yeah.
So like comparing those that stay in the hostel, right, like maybe they don't drive to school, because I'm not sure like how far the hostel is from like the academic buildings. So like, is it like really impactful in a sense because it's only accommodating to those students staying in hostel? Because I would assume that they stay in hostel means like maybe their parents send them there, and then they only go back during the weekends.
Okay.
Yeah, so that they might not have a car readily available in hostel in the first place. So like it is just more towards like helping the students get around the school rather than like
Okay. So for the question, for undergraduate students in UTP, they all have to stay in campus, and only postgraduate are allowed to live outside the campus. So I could say that this EV bus really beneficial for all of us, since it will go to the class or to the hostel. But at the same time, we also got shuttle bus that can help students going outside UTP. But it's not fully utilized EV bus yet, because EV bus need to have integrated system that can actually go beyond their range. So right now, it only can help. It can only help. It can like only go in UTP routes, because since this is my personal experience also, from my hostel to the academic building, it takes like 15-minute walks, around 2 kilometers, something like that. And it's very like time consuming also, because I need to finish myself by 30 minutes earlier. But my colleagues that use car only can finish themselves around 5 minutes. So this EV bus can be beneficial for us also, since we only need to wait in front of our hostel only, and the EV bus will take us. But I mean, if you compare to other students that doesn't need this shuttle, it's okay because we got other shuttle also to help them go back to their house. Okay, thank you.
Thank you to Ms. Harissa Sufeena. So that concludes our final presentation for today's sharing session. Thank you once again for your active participation. We will now take a short break before moving on to the next agenda, which is panel discussion at 4 p.m. See you all shortly. Thank you.
We have the capacity to Yeah, we do have. There's no but right now we have the current service right now is the traditional bus. But I think with the traditional bus, I need to send students to the shopping mall area, just in the local area. Their dormitory blocks all 5 floors, and each floor has more houses, and each house has 6 rooms. And the last seat dormitory is as we say, each village, right? Why they call villages? Each village has its own student center. So on the student center, you have the cafe, you have the laundromat, you have your parks, you have study space. And recently, we have a new center. So you have a